Now, 2.4, we're just strictly looking at comparing and ordering fractions. So a lot of the stuff we just learned in 2.3 is going to be applicable here because we're going to be scaling fractions perhaps up or down, but what we really need from these is what we're going to call common denominators. What that is going to do for us is it's going to make each size of the pieces the same, then we can just compare how many there are. And while that may not make a lot of sense right now, hopefully it will by the time we finish. All right, I guess I kind of spilled the beans on that last slide, but this one's pretty much saying the same thing. It's all right, we can go over it again. But what we needed is the denominators to be the same because that will give us the same size parts, okay? Because if you were to take like a pizza and split it in half, and you have the same size pizza and split it into thirds, the pieces are different sizes right there, and it doesn't even matter what the numerator is. So what you got to do is you got to take your pizza and you got to split it up so that the sizes can be the size of the pieces can be compared the same. So if I had this pizza right here and I had another pizza right here, the same size, hopefully. So the first one, we would say, you know what, we're going to cut this in half. Okay, there's cut in half right there. Okay, well, what if I cut it into thirds right there? Okay, fair enough. Let's cut this into thirds. And yeah, this may not be exact, but I'm doing my best. Okay, my problem here is that the sizes of the pieces are not the same. So how can I make them the same? Well, what I can do is I can take my halves, I can keep that cut right there, but what I can do is just kind of apply the thirds cut just into each of the pieces. So here's what I mean. I've got my half cut right. What I'm going to do is split these each into thirds. That's going to help me out there. Now, this may not be the best, but we're going to do it like this. Okay. Now, please pretend like, you know, it's a good cut right there. Some math people get really upset because, you know, there's some space there. So I'll make that line bigger. That's okay. So what I end up with now is instead of halves, I've now cut each of those halves into 3 pieces, and now I'm left with sixths, right? But I'm going to take my thirds, and I'm going to kind of reverse it. I'm going to take my thirds and split those into halves each. So this would be a half, that's a half, that's a half. You notice that we end up, well, and my drawing's not great, but now I've got 6 pieces right there. So now this would be in 6th size pieces as well. But making those size pieces the same allows me to compare the number of pieces that there are. So if I went back, let's say that I had 1 of the halves, okay, well, that would have been, I'll say the top part here. And yeah, my drawings aren't great, and staying within the lines isn't my strong suit. But that would be 1 of the halves, which really is now showing as 1, 2, 3 of the parts, which are sixths size, so that would have been 3 of the sixths. 1 of the thirds, if I were to go back again, would have been this piece. I'll say this piece right here. But now, when I compare, it's only 1, 2 of the pieces, so that's 2 sixths. Oh, I should have made this here as 1 of the thirds. Okay, so if I were to compare these, 3 sixths is definitely more pieces than 2 sixths, but the sizes of the pieces have to be the same. Okay, well, how do you make these the same? Well, that's where we get into some math. And the math will include obtaining either the lowest common multiple, which I don't always use, by the way, because sometimes it can be fairly inconvenient. So you can, if you would like to, you can use a common multiple. They just have to be common. A common multiple for our denominator will give us the same size pieces. We don't care how many pieces there are. Like if this was split into 12 pieces and this one into 12 pieces, I don't care. I could then see that you'd have 6 pieces compared to 4, and that's okay too. I still know that 6 pieces is more than 4. That's all I would have to look at in the end, but I have to get those size pieces the same. So we've seen 2 methods for finding the lowest common multiple. One was to make a list of the multiples. The other was to find the prime factorization. Now, this is only if you're specifically going for the least common multiple. Like I said, we don't need the least common multiple. I can find a common multiple fairly quickly. So I'm going to do this next problem using all three methods, and then we can compare. Now, going back to, before we get started though, going back to our symbols, this is a less than symbol, this is greater than. And once again, I know the less than symbol kind of looks like a capital L, just kind of tilted a little bit, but you got to choose however you want. Whatever case, this is the less than symbol, this is the greater than symbol. So when we write these out, it needs to be eating the bigger of the two values. Again, that'll be the bigger of the two numerators once we get the denominators to be the same. Get the denominators to be the same, and then you can compare the numerators. It really is in order there. So perhaps I should have labeled this as 1 and then 2. So with that in mind, let's do this. Well, I'm going to do it 3 times. Okay, so 1, 2, and then 3, all right? Of course, the answer is going to be the same no matter which way we do it. But first, let's start by making the denominators the same. So I'm going to do the work below. But I would make it with multiples of these values, meaning the denominators, okay? So here you do 13, of course, is its own first multiples, but then I would have to add 13 to get 26. Now, you could go further than that if you'd like, but I'm not going to because I know 26 is a multiple of 2. How do I know that? Because 2 is even and 26 is even. Eventually, I can make 2 of 26. Here are the numbers: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and then 26. So my new denominators should be 26, and that would be our lowest common denominator. Okay, well, we got to scale the fractions though, so how did we get 26? Well, 26 is the second multiple of 13, so I'd have to do 2 times 13 to get the 26 denominator. But if I do it to the bottom, I must do it to the top. That's what we learned, at least in the last lesson, maybe 2 lessons ago. But in the numerator, 2 times 7, in the numerator, boom, 14. Okay. Okay, well, what do I have to multiply 2 by to get to 26? Well, that was the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13th multiple of 2. So that means 2, you'd have to multiply it by 13 in order to get the 26th denominator. And then I'd multiply the 1 by 13 in the numerator to get, well, 13. So I now have the same denominators, which means that I pretty much can ignore them and simply compare the numerators. And I know that 14 is bigger than 13, which means that originally the fractions that we had, the 7/13, is bigger than 1/2. Now, I just answered these other 2 ways, but again, we're going to show it in 3 different ways. So finding common denominators, the lowest common denominator with a list. So this is our listing method for lowest common denominator. I said denominator, really it's the lowest common multiple, which makes them the denominators here. The next method is to use prime factorization. All right, so with this method, we're still going to have 2 fractions to compare, but we'll end up simplifying those fractions and seeing what's left. So I'm setting up future fractions here, which you may or may not do right now. It's up to you. But I'm only looking at the denominators. Well, the denominators, and this is great for us, but 13 actually is just, it has a prime factor of 13. Well, you'd say 1 and 13, but 1 is not prime. 13 is. So the prime factorization of 13 is actually just 13. 2 as well. 2 splits up between 1 and itself only. 2 is the only one that's prime, so 2 is the only prime factor. Now, this one, the way we have it set up, it has no common factors. There is none. So what we have to do is multiply the uncommon factors, which are 13 and 2. Let's multiply those together, and this will tell us the new denominator of, well, 26. So we've seen that 26 before. I guess I didn't need that extra fraction right there. Okay, well, what did I multiply to get this 26 right here? Well, the 13 I had to multiply by 2, which is already being shown. I guess we've actually already done that work as well. But 7 times 2 there's going to be 14. We already did 2. 2 would have to be multiplied by 13, which is 26. So 1 times 13 would give us the new numerator of 13. But again, we have the common denominators, which means that all we need to do is compare the numerators. And again, 14 is bigger than 13, so still a greater than symbol. Now, if you consider both those to be a lot of work, the prime factors wasn't a lot of work, in my opinion, just because 13 and 2 were already prime. So we didn't have to divide them by anything, really. We didn't have to find any other factors. That's good. But now I'm going to go to 7/13 and 1/2 here at the end and just find a common denominator. And with this method, I do not care about lowest denominator. I don't care about lowest common multiple. I don't care about that. All I need is something that is common. Well, as it turns out, this method will sometimes provide the lowest common denominator. Anyways, so here's what I do. I take the denominator 1 fraction, which in this case is 13, and I simply multiply it into the second fraction, both the numerator and the denominator. Well, 1 times 13 is 13. 2 times 13 in the denominator is 26. Then I take the second denominator, which is 2, and I simply apply it to the first fraction, both in the denominator and numerator. So in the numerator, 7 times 2 is 14, and in the denominator, 13 times 2 is 26. Well, since those denominators match, all I've got to do is declare 14 as being bigger than 13. 14 is greater than 13, and so I can fill in the gap between my original inequality. So 3 different ways you can do the listing to find the lowest common multiple. We did prime factors, which also is another way to find the lowest common multiple. But I like common denominators with just finding a common multiple by simply multiplying the denominators by the other fraction. Now I know that's 3 different ways. You don't have to use all 3 ways. You just choose the one that you like the best and then use it. I like this way, so unless it asks specifically for the lowest common denominator, I will not be using it. I like this method. I don't have to think very much about making a list or breaking it up into its prime factors. I just multiply, and then I can compare the numerators. All right, this one, we don't need any lowest common multiple. We don't need any prime factorization here. All I'm going to be doing on this one is forcing the denominators to be the same. Now, as it turns out, by doing it this way, we will again have the lowest common multiple anyways. So here's what I mean. I'm going to take the 3 denominator and I'm going to multiply it into the other fraction, both the numerator and the denominator. So what does this give me? Well, in the numerator, 8 times 3 is 24. In the denominator, I have 10 times 3, which is 30. Now, before I even do any more math, I will expect this denominator to be 30, but let's make sure that it is. I'm going to take the second denominator, 10, and I'm going to multiply it into the first fraction, both the denominator and also the numerator. So the denominator, check this out, 10 times 3, boom, 30. Automatic match. It automatically will match every time. In the denominator, I've got 20. And now I have common denominators, which means I'm looking at the same size pieces. I just need to know which one has more pieces. Well, 24 is definitely bigger than 20, so I would expect that to eat 24. So in the original fractions, 2/3 would be less than 8/10. So again, did I have to list any values for 3 or 10? No, I did not. Did I have to do any prime factorization? No. All I had to do is take these two numbers, multiply them. Now, these numbers are fairly small, so they're also fairly easy to work with. They won't always be that way. So again, if you want to use prime factorization, that's fine. But even the multiplication, if it was like 58 times the 38, I don't care. I would still rather do that multiplication than compare the numerators. So on this one, okay, if you found the lowest common multiple here, well, you'd find out something interesting, okay? And that is that 18 is actually an already multiple of 6. Now, if you knew that, you could just scale the 6 up into an 18. So let's go ahead and do that. I'll still do this by making the denominators the same and a little different. But for now, let's say that we knew, and again, this takes some experience, but if we knew that 18 was a multiple of 6, it'd be the third multiple of 6 in order to get a common denominator of 18. Well, then you'd multiply the numerator by 3 as well in order to get 3/18, and then we would be comparing 3/18 with 3/18. As it turns out, these two are exactly the same. It's the same numerator, same denominator. And that can work. But again, I'm pointing this out because some students don't really need to do this multiplication. They see the 6, they see the 18, their common multiple. Okay, just scale this one fraction. We didn't have to do anything with this one. But again, not everyone may see that, and so we may need to take our fractions and do a little bit of multiplication. All right, so I would take the 18, first denominator, and I would need to multiply it into the denominator of the second fraction, but also the numerator as well. The numerator, by the way, is easier. 1 times 18 is 18. But then we'd have to do the work. Yep, we're going to have to do the work for 18 times the 6. So 6 times 8 would be 48. Carry the 4. 6 times 1 is 6, but adding the 4 makes that 10. So my new denominator for 1/6 would be 108. Now that's big. It doesn't matter how big it is because we just need the pieces to be the same size. Now here's the thing with this. The second denominator is already 6. I already did the work for 6 times 18. So I already know this denominator is going to be 108. So we'd then have to do the numerator 3 times 6 in order to get 18. Once again, we have the same size pieces, 108ths, and the numerators are exactly the same, so we would say they are equal, which means the original fractions are equal. And that's it. So again, this first method takes some experience, takes some time, some practice, before you may realize that one of the values is simply a multiple of the other. But if you didn't, just do the multiplication thing. See, that I wouldn't even say that took a lot of extra work or time. It does take extra time and it does take extra work, but you still get it at the same answer, and that's the main thing. So that brings us to this slide. It's asking, is it close? Just like it will in the assignment. But when making a fraction close to another value, you have to compare the numerators and denominators. That's true. So using the fraction given, you'll take the denominator, which is the bottom, and it should be some kind of multiple of the numerator, which is the top. So what I do is I take the denominator, or the numerator rather, of the unknown fraction, and I can multiply it by whatever that value is. Okay, so for example, if they give me a fraction of, let's say, 1/2, 1/2 there, then I know that I'd have to take the 1 compared to the 2 would be 1 times 2 to get the 2, okay? Now, if they give me another fraction where they give me the numerator, let's say it was like 4, then I would have to multiply the 4 by 2, just like we did in the first fraction, and that would give me the new denominator. Now, that gives me a new denominator, but notice these fractions are the same. What we need to check then is the new fraction going to be smaller or is it going to be bigger? If it's smaller, then if the new fraction needs to be smaller, then we can subtract 1 from the numerator. or add 1 to the denominator. Both of those are going to do essentially the same thing. If we need the fraction to be bigger, then we take the numerator and add 1 to give it more pieces, or we subtract 1 from the denominator to make the pieces bigger. Okay? Now, let's say that the denominator was missing, and let's compare it to 1/2 because it's a fairly easy number to work with. So once again, I would say I know 1 times 2 is going to be 2 there. But if I were to compare this to another value, let's say something like 10 right here, and then I need a numerator, right? Well, then I'd have to see how I multiplied by 2. Now I'm just going to divide by 2 to get my new numerator, which would be 5. And then I follow these rules again. Again, if I need to make this fraction smaller, I can just make the pieces smaller, or I can have less pieces, or I can make the pieces smaller. If I need to make this fraction bigger, I can have more pieces, or I can make the pieces bigger by subtracting 1 from the denominator. So it depends on what it needs and what it's asking for, but we need to see the fraction that's given, the relationship between the top and the bottom, the numerator and denominator. So I assume that's pretty unclear. I was doing my best to explain it. I think an example would help us, and really the only reason I have these examples is because we're going to see them on the assignments. Let's take a look. So right here, we want something that's really close to, but also greater than. We'll need to keep that in mind. Looking for something bigger than 1/2. Well, here's 1/2 right there. And I guess that's the values we were looking at, right? I know I'd have to take 1 and multiply it by 2 to get this denominator. So if I was looking at a fraction of numerator of 56, I would multiply it by 2 to get the new denominator. Well, 56 times 2, 2 times 6 is 12. Carry that 1 over into the next place value. 2 times 5 is 10, but adding the 1 that we already had carried over makes that 11. So we have 112 as our denominator. Now, I'm not going to fill in this blank with 112 because I need it to be close to 1/2, but just a little bit bigger. So if I'm working with the denominator, I can make these pieces bigger by simply taking 1 away. So I'd say 112 minus 1 would give me a new denominator of 111, and that's all I need. Just keep in mind, if we were looking for the numerator, I would want more pieces to make it bigger, to make it greater than 1/2. But this is about as close to 1/2 as we can get with a numerator of 56. It's as close to 1/2 as we can get, but also bigger. For this one, it's actually not showing the denominator there. That's okay. We can make it a fraction. Just anything, if it's not showing a fraction, we just make it over 1. We've seen that with division principles and properties and rules and laws and whatever. But what I see here, that it's just the same number on top and bottom. So if I were to compare a new fraction with a denominator of 51, I would make it exactly 1 by making the numerator 1 as well. So just like my 1 over 1, it matches both numerator and denominator here. But at the top, it says we want something really close to, but also less than 1. So to make that less than 1, I can either have less pieces, which is the numerator, or I can make the pieces smaller, which is the denominator. Oh, that got cut up there, didn't it? Let's move it. Now, I'm dealing with the numerator because the 51 is going to stay. So since I need to make this just a little bit less than 1, I need to make there less pieces. So I'm going to take the 51, subtract 1, which would be 50. That would be my new numerator, 50. So this means that this value right here, I don't know what the decimal is, I don't care. It's just that this value is very close to 1 that we started with, but also less than 1. Bam, that's it. Now think about this. Let's say that it said greater than 1. Well, then I would have to have added 1 piece to my 51 to make 52. That gets me just a little bit above 1, but as close to 1 as I can get if the denominator will remain a 51. All right, what number is 48/5 closest to? Well, to figure this one out, we're going to need some long division. Unless you know your 5 multiples up to 48. Well, 5 doesn't go into 4, so I can put a 0 there, but it will go into 48 9 times. I'm skipping a little bit of the math there, but 9 times 5 is 45. So when I subtract that out, I now have a remainder of 3. So as a mixed number, let's change this into a mixed number. We have the whole value, 9. The denominator stays a 5 as it was up here, but my numerator is the remainder of 3. So I have 9 3/5, which means I only have 2 options, and I'm looking specifically at the whole number. It could be close to 9, but it could be close to 10. Now, if you make a number line, which may be helpful for some of you, there's 9, there's 10, and well, you'd want to make this proportional, but I'd split it into 5 parts, which means I need 4 partitions. 1, 2, 3, 4. Okay, so that's 5 parts right there, and they're not great parts, but the third of those fifths would have been at this mark, this partition. And then we ask, is that value, that purple mark there, is it closer to 9 or 10? Well, from what I can tell, and it's not just because my drawing sucks, but this is a lot closer to 10 than it would have been to 9. See, it's kind of a longer line right there to get to 9, or to get to 10, it's a smaller green line, which means that 48/5, which also as a mixed number is 9 3/5, it's actually closer to 10 than it is to 9. And that's it. Now let's say that we start with 47/5. Well, then we would have been on this mark. Again, that would have made this line smaller than this one, and then it would have been closer to 9. We have to be careful. The number line may be helpful, but if it's not, then another way to do it is you could make the denominator something bigger or smaller. You can divide it by 2 and then see how that works, or if the number is bigger or smaller than that. That's a little bit more work, and it ends up causing more confusion for students, so I'm not going to do it that way, but you're welcome to do it that way. It is a way. Now, these problems, you're going to see these types of problems on the assignment. Compare the fractions using benchmarking. Look for a benchmark fraction, 0, 1/4, 1/3, 1/2, and also 1. That each pair is close to. So on this one, we'd say, you know what, just see if we can figure out which benchmark to use. Now, to figure out which benchmark to use, you can look at the values, and this takes some experience and some thinking involved. But you can look at these and say, well, let me just change some of these a little bit so that it makes something that's a little bit easier to work with. Specifically, we want values that can either be cut in half, whether it's the top or bottom, or maybe they can be doubled or tripled or quadrupled, or cut in fourths or thirds or something like that. And when we say fourths or thirds, it means we're dividing values by, if it's fourths, then we're dividing by 4. If we're looking at thirds, then dividing by 3. But we can also multiply it by 3, depends on which one you want. For me, I like to see values with zeros or like multiples of 5, so 15 and 80. But I like ones with 0. So I would look specifically at the 39/80ths. Okay, now I would keep the one with the 0, but I would look at 39 and say, well, how do I make a 39 something that is related to 80? Well, I know if I were to take the 39 and if I were to add 1 to it, I would get 40. The reason I want 40 over 80 is because this breaks down into 1/2. So you could divide this by, both of those by 40 and get 1/2. Okay, now this tells me that we are using the benchmark of 1/2 to make this comparison. Okay, so 39 over 80 is just below 1/2. And 15 over 32, again, that's pretty close to 1/2. But I would know, and this takes some knowledge, but if you're looking at 15 over 32, really you could have just said, well, I'm going to take that 15 and I'll go ahead and just multiply it by 2. And that gets us pretty close to 32, right? To get us that bottom denominator value of 30. And then we can make the comparison. Now the problem is 32 means that you'd have to add 2 more to actually get the full value, which means that you'd be making the pieces smaller. If you get more pieces to make a whole, then you're making the pieces smaller. Here, we kept the same size pieces, but we ended up having to add one of the pieces to make that 1/2 right there. So is adding 2 extra pieces going to make this number bigger, or is adding an extra piece here going to make this one bigger or smaller? And again, this may take some thought. Now, if I had to choose between these, I'd say adding an extra, I guess we'd say 80th, is going to take a lot less to get to 1/2 than adding 2 extra 30th size pieces. So for me, I would say right here that 39/80ths is bigger. Now, another way to check, because I feel like this is not very clear on how to expect one to be bigger or smaller than the other, you could just use what we did earlier, where you just take the 32, multiply it by 80, 80 times 32, and then 15 as well, and then 39. Also, you get common denominators, and then you can compare the fractions. Now, if you did that, you would have gotten these 2 fractions, and yes, we can see clearly that the 1,248 is definitely bigger than 1,200, but again, you would have had to have forced those denominators to be the same. So, kind of 2 parts to this. I mean, they're going to say, well, which benchmark would you use? 1/2, you have to know how to get that 1/2, but also then you have to make the comparison, which I don't really care if you use the benchmarks to make the comparison, because I think just actually multiplying these is a lot easier. But it's up to you. Well, that brings us to fractions and number lines, and again, we're going to see this on the assignment. So the denominator is telling you how many parts each unit is split into, not marks, but parts, okay? So if it asks for partitions, which it might, we may have to split these partitions up into a certain value, but you just take the denominator and subtract 1. And then the numerator tells you how many parts each unit has been split into. So we'll be making comparisons with these, and the number lines may be helpful. We'll find out. So right here we got 2/8 and 2/6. Notice it's the same exact comparison. It's just they flipped the 2, and that's okay. Okay, so the first one, 1, 2, 3, 4, 5, 6, 7. So these aren't my 8s right there, because I got 7 partitions. 1, 2, 3, 4, 5, 6, 7, 8 parts to make this one whole. Notice that they're exactly the same lines, but this one is now been split up into 6. So I need to identify the 2/8 mark on my 8ths line, which would have been right here, because this would have been 1/8 there. But we're looking for 2/8, which is here on my number line, which means that correspondingly I can kind of transfer it down right here. That's where 2/8 would be on this, even the 2/6 number line. But the markings, this first one would have been 1/6, and then I need 2/6 though, which is further to the right than what I had at 2/8. So again, if I were to transfer this up, it'd be somewhere like right here. So 2/6 is further to the right. And that right there is enough to see that 2/6 is bigger. That tells us we're looking at something that is bigger, okay? So 2/6, for my inequality, would have to be eating it no matter where it is in comparison to 2/8. So we could read this, 2/8 is less than 2/6, or 2/6 is greater than 2/8. Both are true. But you make these comparisons on both number lines, and then you see where they are in relationship to each other. If they were in exactly the same spot, then we'd have to say they're equal. I don't think we're going to see a lot of those, but you might on the assignment. Okay, ordering values from least to greatest, it is going to take some thought, okay? You can just multiply all the denominators by each other and see what you get from everything else, but it's way more multiplication than you're ever going to want to do. So we are going to make the denominators the same, but we're going to have to look at these. They're not going to give us values that are so freaky that there should be a lot of multiplication involved, but there will be some. Once you get the denominators the same, then you order the numerators from least to greatest, and then you compare the originals together, writing them in order, usually from least to greatest, but we'll see. Okay, so see if some of the denominator values are multiples of the other denominators. That's what we're going to be doing on this, which is part of taking time to do these without taking so much time to just do a bunch of multiplication, because eventually you start multiplying very, very, very large numbers, which we're trying to avoid, although you could. So on this one, I look at my denominators. I don't care, right now, I do not care about my numerators. Let's just separate these denominators and look at them as values. Well, after looking at these, again, you could think back to your multiplication table. All of these are actually 10 and 20. They're both multiples of 10, but all of these are multiples of 5 because they all end with 5 or 0 in the ones place value. So this means I can obtain each of these simply by multiplying by some kind of multiple by 5. Multiple of 5. Each of these is a multiple of 5. Now, this means also that we're going to take the low ones and we should be able to make them something bigger, okay? Like 25, maybe 10 or 20. I can make a 5 a 10, I can make it a 20, I can make it a 25. But I can't make a 10 a 25 very, directly, and I can't make a 20 a 25. So I got to think beyond just the fact that these are all multiples of 5. And in that case, it may be helpful to make a multiples list of one of usually the value that's the most inconvenient. So 10 and 20 and 5, I would say those are all fairly convenient. But 25 isn't so convenient. So I'd look for multiples of 25. It's its own first multiple. Add another 25 to get 50. Okay. Well, 50, it will work for the 5 again, but not 20. It will work with 10. So I'm going to add another 25 to that. That'd be 75. Okay, now it only works with 5, but not 10 or 20. And you'll see now when I find the fourth multiple of 25, which is 100, that is a value that's going to work for all of them. Okay? So that's my fourth multiple of 25. So I can go back, and what I will expect is to make all the denominators, all 4 of them, I'm going to make 100. Because 100 is just a multiple of all of these, all 4 of the denominators. So the 25, I see it's multiplied by 4 to get 100, but I'd have to multiply the 22 by 4 as well. So we'll do that multiplication down here, 22 times 4. 4 times 2 is 8. 4 times 2 is 8. That gives me 88 100ths. All right. Okay, well, 20. To get to 100 there, what do I have to multiply 20 by? Well, I'd have to multiply, well, you could just add them, by the way, but 20 is its own first multiple, plus another 20 is 40, plus another 20 is 60, plus another 20 is 80. That's the fourth multiple, and then the fifth multiple, add another 20. Boom, we've reached 100. So the 100 for my 20th means I'd have to take the 20 and multiply it by 5. So I'll have to take the 3 and multiply it by 5 as well to get 15. These two values that we've just found, and I don't know why I went to 3/20ths. You could have went in anywhere you want. But 15 over 100, this is a lot less pieces than 88. So just between these two, I know 88 100ths is much bigger than 15 100ths. But then we got the denominator of 10, so I'll use green here. So 10, I know I'd have to multiply that by 10 to get 100. It's the 10th multiple of 10. So over here I would say, well, 10 times 10, that's the 100 denominator. But the numerator, 7 multiplied by by 10 would give me 70 hundredths. So just between these three, I can put these in order already. 15 is the lowest, then 70 is the next biggest, and then 88 is the biggest of these values that I have. Now, 5 is a little weird, I suppose, but I'll skip the addition and just show that 100 is the 20th multiple of 5. So that means in order to get a 100 denominator for 5, I'd have to multiply that by 20. Some of you may wonder, well, how did you get 20 right here? You can just do 100 divided by 5 with a fact family. But if I multiply the denominator by 20, I've got to multiply the numerator by 20 to get 40. So these are my 4 numerators. And if I was to compare these from least to greatest, the smallest one would have been the 1500, excuse me, the 1500ths. Okay, so we've used that one. The next biggest is 40 100ths. So I move that here. And I'm ordering now from least to greatest. And then we're only left with 70 and 88. Well, 70 is definitely smaller than 88. So we have the 4 fractions. Now we manipulated those fractions. Now we got to go back and we're going to relist these, but in order from least to greatest. So the original fractions, where'd they come from? Well, the lowest one, let's start there. The lowest one is the 3/20ths. Okay. It's the 15 100ths, which came from the 3/20ths, so that's my smallest one. Next, the 40 100ths came from the 2/5ths, so that would be the next biggest, 2/5ths. And then the 70 100ths came from the 7/10ths. And finally, the 88 100ths came from the 22 25ths. And now this is in order from least to greatest, which is exactly what we wanted. Okay, well, let's do these fractions in order from least to greatest. Again, I would kind of look for the weird one here. 7, I'd say is pretty weird, but 14 is the second multiple of 7. So I'm going to say that's my weird one right there. So let's take these denominators and just start comparing them. Okay, so 14, again, I can't use 14 because it's not a multiple of 4. It is a multiple of 2 and 7, though, so we're pretty close. And as it turns out, if I add another 14 to that, then I get 28, which is a multiple of 7 and 4, and it's divisible by 2 because of the 8 and the 1's place value. So I can scale up my 1/14 simply by seeing that 28 is the second multiple of 14 to get a new denominator of 28, but I would have to scale the numerator 1 times 2 to get 2 28ths. Okay, and I can get 28ths out of 7, 2, and 4. I guess I'll start with the 7. I'll go from left to right this time. So 7, I know I'd have to multiply that by 4. You can make a list, but 7 times 4 is going to equal 28. So over here, where I've got my 7ths, I would need to multiply that by 4 to get the new denominator of 28. But if I do it to the denominator, I've got to do it to the numerator as well. In the numerator, 3 times 4 is 12. Next, we'll go to the 2 denominator. So that's going to be 2 times 14. Now, how did I get that? Well, 28 is the second multiple of 14, so I know I can reverse them. And if I do that, I get 28. You're all going to make a list there, or just take 28 and divide it by 2. It's the same thing. So that fraction will be in 28ths because you can take 2 and multiply it by 14, which means also you need to take the 1 and multiply it by 14 as well to get, well, 14. Now, these 3 fractions, we're not finished, but you can start your comparisons. Of course, 2 is much smaller than those other 2 because our denominators are all matching. We can make those comparisons. Now, 4, what do we got to multiply 4 by to get 28? It'd be 7. Again, you can make a list there, but 4 times 7 is 28. So over here, I'm going to multiply the 4 by 7 to get a new denominator of 28. But so as not to change the actual value of the fraction, I'll have to multiply the 3 by 7 as well. And that gives me 21 in the numerator. Okay, so in listing these from least to greatest, the smallest one that I have is the 2. And again, I'm really just comparing the numerators. The next biggest one is 12. 12 is the smallest between 12, 14, and 21. And then finally between 14 and 21, well, 14 is definitely smaller. 21 is much bigger than 14. And now we have placed these in order from least to greatest, but we need to write their original fractions down. So Start with the 2/18. I'll start with the smallest one. That came from 1/14. 12/28 came from the 3/7. 14/28 came from the 1/2. And 21/28 came from the 3/4. So this now has listed the original fractions in order from least to greatest, and that's our answer. This last problem for this section, when adults were surveyed about conserving and recycling, 1/4 of them said they conserve water, while 2/6 of them said they use reusable containers at home. Which group represents the greater number of adults? So this means that we're comparing really 1/4 with 2/6. So 1/4, that came from the people that conserve water. And then the 2/6 came from the containers. Sorry, containers is a hard word to spell for me. In any case, we're just comparing these two, so we just need to compare these with common denominators, and that will help us to determine these two fractions, which is bigger. So I'm just going to use the old-fashioned method. I'm going to take the 4 denominator and multiply it in the denominator and numerator of the other fraction. 2 times 4 is 8, and 6 times 4 is 24. Since we're using this method, I'm expecting this denominator to be 24 again, which means you'd have to multiply the 6 denominator into the denominator of the other fraction, and 6 times 4 is 24. That checks off. But if I do it to the denominator, I must do it to the numerator as well. So that's 6/24. I know that 8 is bigger than 6, which means that the original fraction's 1/4 is less than 2/6. And that's it. Also, which group represents the greater number of adults? That would be the ones that use reusable containers. There we go. And that'll complete comparing fractions for us. So now hopefully you can see all we're really doing is comparing and ordering the fractions. And if you feel good about that, especially all the problems we went over, then the assignment will go well for you. If not, you may struggle, but still try and ask questions.